Hello students, welcome to the next part. In this part, we'll talk about power of lens, right? Like what exactly is the power of lens? Why does it matter, right? What significance does it have, right? We'll talk about that. So let's start. So basically, the basic formula is, or the definition of power is reciprocal of focal length in meters. This is very important. In meters is known as power of lens, right? What is the SI unit? SI unit of power of lens is diopter. Diopter, TRE, is also signified as D. And the formula is power of lens P equals to 1 over focal length in meters. That is, if we talk about focal length in centimeters, you can also have this formula 100 by F in centimeters, because 1 centimeter equals to how many meters? 1 meter by 100. I mean, 1 meter equals to 1 centimeter by 100. So if you exchange meter by centimeter by 100, 100 will get in the nominator, and it will be the final formula if you want to have focal length in centimeters. Diopter in air, right? Now, if we talk about combination of lenses, right? Now, what is combination of lenses? If two thin lenses are placed in contact to each other, right? That is like this, right? Then power of combination is nothing but P equals to P1 plus P2. That is 1 over F, that is the total focal length, 1 over F1 plus 1 over F2, right? Always use sign convention when you solve numericals, while solving numericals, right? So two thin lengths. So these were if they were touching each other. Now let's take an example where two lengths are separated by distance D. This is F1, F2, two thin lengths are placed in a small distance D, right? Provided incident rays are parallel to the principal axis. This is very important. Provided incident rays are parallel to x-axis, right? Yeah. So it will be 1 by F. The formula is 1 by F equals to 1 by F1 plus 1 by F2 minus D over F1, F2. And this extra term is coming, right? P equals to P1 plus P2, power of length 1 plus power of length 2 minus D of power of length 1 multiplied by power of length 2. Right? Again, use sign conventions, right? Now, there's a Newton's formula in this case. That is, if there is a lens, right? This is the principal axis. Okay. There is an object O, image I, focal focus point f1, focus point f2, length is f, right? And the distance of object from lens is u. The distance from image from lens is v. Let's suppose this distance is x1. Let's suppose this distance is x2. Then Newton's formula says the focus will be root of x1 multiplied by x2, where x1 is distance of object from focus and x2 is distance of image from focus, right? So this was an extra point after the power of combination of lens. Right? This was an extra point because advanced generally asks questions in mixed with these formulas. And if you want to know more about optics or this chapter, you can directly contact me in Urban Pro by my name, Utkal Roy. Right? Thank you so much for listening, guys. That was it about power of lenses. Thank you.